My name is Savell Robinson, and this is my project, Insertion Mutation Library for the Identification of Serratia marcescens virus. Okay, so to start off, I'm just going to talk a little bit about what Serratia marcescens is. It's rod-shaped, gram-negative, anaerobically facilitated. It can infect a lot of things, including humans, crops, and even some insects. But the big thing that we're studying here is what causes this infection. Preliminary studies have shown that extracellular proteins and secondary metabolites may be the cause of this, but in order for us to do our experiments, we are specifically looking at its effect of virulence in Drosophila melanogaster, and to do that, we developed non-virulent mutant strains from a transposon library. Just to give a little bit of background on why we're using Drosophila melanogaster, it is a model organism in biology. Its immune system, due to extensive research in genetics, is well understood, and its several pathways are very ambiguous to a lot of other insects that we use in research. So we can use this organism as a baseline. We have three aspects to this project, the first being our transposon library that we created. Basically, we took a strain of E. coli given to us, and we facilitated a suicide plasmid transfer. So separately, both of these things are pretty resistant to antibiotics, but once this suicide plasmid transfer takes place, then alone our recipient should not be resistant to antibiotics. And this process and this transfer was in fact successful, so we took it one step further and started screening its effect on virulence with Drosophila melanogaster. And in order to make this all correct scientifically, we had to locate the specific location of the suicide plasmid transfer. So this is what we did during this slide. Now, while screening, we noticed that there was a decrease in death numbers, but that death numbers were still happening. So we had to look a little bit closer to figure out why exactly this bacteria was killing the flies. We attributed this effect on virulence to metabolites, meaning that in our non-virulent mutant strain, there was some type of metabolic process that has been turned on, allowing these flies to break down this bacteria and to decrease their death numbers. So I'm just going to flick through these graphs really quickly. You can see here that we are testing the death numbers of multiple mutant strains. Here we're looking at the death numbers with 100% infection rate so that we can see if we need to actually test the secondary metabolites. Here we're basically putting everything into words, and then here we're actually looking at the specific metabolite that we screened for. Here we're basically just discussing how our first two aspects of our project were successful, and then our second half of the project where we identified the specific metabolite but we weren't able to actually test it and see the significant effect on virulence. You can read over this if you'd like.